Hello, we're going to continue our V-belt drive design problem with step 7. Step 7 is to specify a trial center distance. And the reason why I say trial is this is just based on the geometry of the sheaves. And really by the time we select this center distance, it's going to get us close, but we're going to have to find out what the belt length is, and we're going to have to calculate a standard belt. So, step 7 just really gets us close. And we were given an equation for the center distance, an acceptable range for the center distance. And so when we calculated it for 717, we get anywhere from 21.1 to 100.5 inches distance between the centers. And any center distance CD in that range would be okay, but in this case we're going to choose to keep our machine smaller, and we're going to select a center distance of 24 inches. Again, this is a design decision, and then we're going to use that to calculate what the belt length is, and we have an equation for that from 712 to calculate the belt length, and that's just based on the center distance that we had started with up here and the geometry of the sheaves. So when we calculate that, we end up with 101.4 inches, which isn't a standard belt. Okay, because step 9 tells us to go find a standard belt and calculate the actual center distance. So we're going to look at this table 7.2, and right here we have 3V, 5V, and 8V belts. They will have a 100-inch length available. So let's go select that 100-inch length. And so now that we have our actual length, we can calculate what our actual center distance is. And we're going to do that using equation 713. Equation 713 has two steps to it. It has this B parameter, and then it also has the sheave geometry in there too. So when we solve these two equations for CD, we get an actual center distance of 23.3. I mean, it just kind of makes sense. We choose 24, but our belt length that we calculated was not available, so we had to go a little bit smaller with 100 inches. So therefore, our actual center distance is going to be 23.3 inches. Okay, now coming down to the last 3 steps here. Step 10 is calculate the small sheave angle of wrap. And we're going to use equation 714 to do that. And again, it's just based on the geometry. And really, this is how far that belt wraps around the smaller sheave. And we need that for a correction factor in step 11. So let's go ahead and calculate our angle of wrap around the smaller sheave is 158. And then we're going to go to step 11. That's to determine the correction factors. Okay, and there's 2 of them we have to look at. We're going to consult figure 718, this one right over here, for the angle of wrap correction factor. Really, all we're going to do is we're going to take our 158, which is pretty close to 160. We're going to scan up until it intersects the red line. And then we're going to read off the y-axis approximately 0.94. So I get that as 0.94. And then we're going to consult figure 719 for the belt length correction factor. We have the belt length in the x-axis, and then we have these 3 red lines for the 3 different belts, cross sections. So we're going to take 100 inches, and we're going to scan up to our 5V line, and we're going to read off right around 96. Okay, so 96 is going to be our correction factor for belt length. Step 12 is going to be calculate the corrected rated power per belt and the number of belts. So we're going to do that by multiplying our 27.55, that was our rated power, times the two factors that we just found, and therefore we get a rating of 24.86 horsepower per belt. Okay, so if we take that, we needed a 65 horsepower for design power. If we divide that by the 24.86, turns out we need 2.6 belts. So we're going to round that up to 3. Okay, so now we can summarize this V-belt drive design. First of all, we have an electric motor coming in at 50 horsepower and 1160 RPMs. We have a service factor of 1.3. Our design power is a 65 RPMs. The belt we chose is a 5V cross section and 100 inches in length, and then 3 belts are going to be needed. Now the sheaves we're going to be using are, first of all, the driver is a 12.4 inch pitch diameter with 3 grooves for a 5V belt. The driven is a 21.1 inch pinch diameter, 3 grooves for 5V belts. The actual output speed is going to be 682 RPMs, which is only 1% off of our required 675 RPMs, and the center distance is now 23.3 inches. That is our V-belt drive design. I included another handout in the Blackboard material, and that's a sheave catalog from Martin. We can go in there and we can look and we can find a standard 3-groove belt, a sheave for our belts, and this is like right in the catalog. This is on page 28 if you're so interested. Open up the catalog and look and see what's available. Okay, so this concludes example 7.2 for lesson 4 in machine design. Thank you.